Assalamu alaikum. Today on 22nd April 2021, I'm starting lecture number 2 for week number 8. And today we will learn Bayes theorem and afterwards we will perform some exercise problems. So what is Bayes theorem? Bayes theorem is nothing but an extension of the conditional probability. In the slides, you can see that uh, let me just open it quickly. Yeah. So in this slide, you can see that the rectangular or square box is basically representing the sample space, while this red circle represents a particular event A. Now, if we want to calculate probability of this event A, what we will do, we will calculate three intersection probabilities. That is, we will calculate probability of A intersection B1, then we will calculate probability of A intersection B2, and uh, afterwards we will calculate probability of A intersection B3. Now, the sum of these three probabilities will give us the probability of circle A, that is event A. Now, how we will calculate these three intersection probabilities? We know that we can calculate the probability of an intersection using the conditional probability. For example, we can write A intersection B1 is equals probability of A intersection B1 is equals to probability of B1 multiplied by the conditional probability of A slash B1. Similarly, for probability of A intersection B2, we can write probability of B2 multiplied by probability of A slash B2. Similarly, for the third intersection, that is probability of A intersection B3, we can write probability of B3 multiplied by probability of A slash B3, that is the conditional probability. Hence, what we saw that for calculating the probability of event A, we applied conditional probability 3 times. Why? To calculate different intersection probabilities. And hence, we calculated the probability of the entire circle A. This is all about Bayes theorem. What we do in Bayes theorem? We basically apply conditional probability again and again to calculate different intersections to the extent that we get the probability of a particular event. In this diagram, you can see that the sample space is divided into three shapes, a triangle and two trapeziums. When we take intersection of the region B1, that is representing the triangle, with obviously the circle A, what happens that we get the upward sector of circle A. Then we calculate intersection of circle A with the trapezium B2. What happens that we get the left side portion of the major sector, that is A intersection B2. Similarly, we take intersection of the region B3, the trapezium B3 and the circle A, and hence we get the right side major sector of circle A, that is A intersection B3. And when we add these three intersections, we get the probability of entire circle A, that is event A. So this is all about Bayes theorem, that we start with the conditional probability. Using the conditional probabilities, we calculate different intersections, and then adding these intersections, we get the probability of a particular event. Now coming back to the first page of this slide, can you see that what are the learning outcomes of this slide? They are saying that the first learning objective is to know the definition of conditional probability and the independence of events. So if you recall, in the last lecture where I taught you using some PowerPoint slides, what we learned how to calculate probability, conditional probability, that is probability of A slash B. And we told you that probability of A slash B is basically equal to probability of A intersection B divided by probability of B. So that was the conditional probability that we learned in the last lecture. Similarly, in the last lecture, we learned about the independence phenomena. What was it? We told you that if two events A and B are mutually independent, then we can have two vital conclusions with us. First of all, if we want to calculate probability of A intersection B, we can write it as probability of B multiplied by probability of A slash B. And number two, if the two events are mutually independent, then probability of A slash B is equals to probability of B. Similarly, if two events A and B are mutually independent, then probability of B slash A is equals to probability of A. Probability of B slash A is equals to probability of B, and probability of A slash B is equals to probability of A if the two events are mutually independent. Now, coming to the third goal, uh, they are trying to explain the multiplication rule, and we already taught you that how the probabilities get multiplied with each other. For example, in the last lecture, recall the numerical problem where we solved a problem where one ball was drawn from the first bag and unseenly, basically not seeing the color of the ball, we placed it into the second box. So for that problem, what we did, we basically made a tree diagram, and then we calculated probabilities of different branches by multiplication by multiplication of the individual probabilities of the branch segments. And then what was the rule told? The rule was that along the branches, the probabilities will get multiplied and the probabilities of different branches will be added. Similarly, if we come to the next goal of this slide, it is to explain the Bayes formula or Bayes theorem. So inshallah today we will learn how to apply the Bayes formula to calculate probabilities of a particular event. So you can see that we had almost covered everything regarding these slides, and you know that from where I took this slide is basically from an internationally recognized university known as MIT. So the course covered by us till the midterm exam is exactly equal to the course that the MIT students cover in their university. So I took this slide to make you realize that we are doing a very vital thing that is internationally acceptable. So if you get this skill, inshallah, it will be very helpful in your future, because you will be able to identify different aspects of the problem, and it will enhance your problem solving skills. You will assess the problem, you will realize the problem in every possible angle. These are the advantages of probability theory, that we analyze any given problem with every possible angle. So now coming to back to the uh, lecture. First of all, they are saying that the experiment is that a fair coin, is basically tossed 3 times. So what are the total possible outcomes? We all know that if a coin is tossed 3 times, then we can make 3 circles, and in each circle we will write 2, because whenever a coin is tossed twice, there are only 2 possible outcomes. First possible outcome is head and the second is tail. So for a coin being tossed 3 times, we will make 3 circles, and in each circle we will write a 2. and hence we will conclude that the total possible outcomes for a coin being tossed three times, it is basically 2 multiplied by 2 multiplied by 2, that is 8. Now, since tossing a coin is a binary operation, is a binary experiment, it has two possible outcomes. So according to the Boolean algebra, the 8 possible outcomes of this experiment could be written as 1 1 1 till 0 0 0. And in case of coin, 1 is head, so we can write head head head, and we can start from head head head, and we can write 8 possible outcome till t t t. And we all know, being an electrical engineer, that in Boolean algebra, if there are 3 variables, then the total possible outcomes are 8. If there are two variables, the total possible outcomes are 4, from 0 0 to 1 1. So in this case, since we have tossed the coin 3 times, so we were having 8 possible outcomes. So the sample space, which is being denoted by Ohm here, is covering all 8 possible outcomes. Now they are saying that if it is given to us that the outcome of first toss is head, then what is the probability that a three head occurs? So this is a question of conditional probability, that if a coin is tossed 3 times and we are told that a head is occurring at the first toss, then what is the probability that there will be 3 heads in this experiment? So obviously, as I told you earlier, that whenever we are to solve a problem related to conditional probability, there could be 2 ways. And the first way, that we can construct a new sample space for the given event. So here, what was given? The given event is that on the first task we are getting a head. So what we did, we made a reduced sample space, Ohm complement, and what we or Ohm bar, we can say. So in this reduced sample space, we can see that we basically wrote every outcome that is starting from the first head. So HHH, in this outcome, the first outcome is head. HHT, obviously the first 2 outcomes are head. HTH, the first outcome is head, and again HTT, the first outcome is head. So since they have told us that the first toss, the outcome of the first toss was head, so according to this given phenomena, we constructed a reduced sample space. Now we need to calculate the conditional probability, that what is the probability that 3 heads will occur. So obviously, in this reduced sample, there are 4 possible outcomes, and out of those 4 possible outcomes, there is only one outcome where we are having 3 heads. So the answer of the conditional probability of 3 heads slash the head on first toss, is equals to 1 upon 4. So hence you saw that they are solving the conditional probability in the same manner as I told you in my previous lectures. So just coming to another example, multiplication rule. So as you saw in my last lecture, that I told you this formula in the last lecture, that probability of A intersection B could be written as probability of B and then multiplying it with probability of A slash B. Why we do so? Because probability of A intersection B could be written as probability of B means that first of all event B occurred, and then when the event B has occurred, we can calculate the probability that uh, how many chances are there that event A will now occur if event B has already occurred. So what is probability of A slash B? It is basically the probability that event A will occur in future if we are given that event B has already occurred in past. So what is the question here? They are saying that you are drawing 2 cards from a standard deck of cards. Event S1 is the event that the first card drawn is spade. while event S2 is the event that the second card is a spade as well. So now they want us to calculate the probability of S2 slash S1. That is, it is again a conditional probability. And how we will calculate probability of S2 slash S1? First of all, we will calculate probability of S1. If you compare this conditional probability with the formula written at the second line of this slide, that is probability of A intersection B is equal to probability of A slash B into probability of B. So first of all, we will calculate probability of B, that is probability of S1. So whenever we draw a card from the standard deck of cards, what is the probability that the first card is spades? So obviously there are 13 spades in a standard deck of card. So the probability that the first card is spades, that is probability of S1, is 13 upon 52. Now suppose that this event has occurred earlier. Na? So what we did, we took one card out of the standard deck. It was a spade. We put it at a side. Now, what are the total possible, what are the total number of cards in the deck now? So obviously, since one card is being drawn from the card, so now the total cards are 51. So now if we are interested to calculate probability of S2, and S1 has already occurred. So we will write probability of S2 slash S1 is equals to 12 upon 51. Why 12? Because now in this deck, there was only 12 cards that were spades cards. So, and in total, there are now 51 cards because one card has already been drawn from it. So therefore, probability of S2 slash S1 equals to 12 upon 51. So you can say that probability of S1 is 13 upon 52. Probability of S2 slash S1 is 12 upon 51. And now if we want to calculate probability of S2 intersection S1, it would be 13 upon 52 multiplied by 12 upon 51. That is the thing that how we calculate probability of A intersection B. Okay. Now coming to another example. Yeah, this is the example where the question is that an urn contains 5 red balls and 2 green balls. And we took 2 balls at random from the urn, one after the other, and they want us to calculate the probability that the second ball is red. Okay, so from this urn or from this bag, we want to draw 2 balls at random in succession without replacement. And we want to calculate the probability that the second ball is drawn, that the second ball drawn is red ball. Now, first of all, we will write the sample space of this experiment. If we are only interested in the colors of the balls drawn, then we can say there are only 4 possibilities. The first ball drawn is red and the second ball drawn is also red. Similarly, the first ball red and the second ball green, that is RG. Similarly, the first ball is green and the second ball is red, that is GR in the sample space. And similarly, if both balls are green, then we can write that it is the outcome GG. Okay. Now the question is that if we have drawn 2 balls in succession without replacement, what is the probability that the second ball drawn is red? Notice that they are not interested that what is the color of the first ball. They are interested that the second ball must be red. So how can we calculate this thing? We can calculate this thing by calculating 2 intersections. Number 1, probability of R1 intersection R2. That is both balls red. Number 2, probability of G1 intersection R1. R2. Why? Because we want the second ball drawn to be the red ball. So to calculate these two intersections, what we will do, we will apply the conditional probability twice. For example, for probability of R1 intersection R2, first of all, we will calculate that if the first ball drawn is red, then what is the probability of getting the first ball red? Obviously, there were 7 balls in the urn, and out of these 7 balls, 5 balls were red. So probability that the first ball drawn will be red is 5 upon 7. This is probability of R1 just beneath equation 4. So probability of R1 is 5 upon 7. Now we want to calculate the conditional probability that if a red ball has already been drawn from the urn, then what is the probability that the next ball is also a red ball? So obviously, if a red ball was drawn earlier, then the total balls in the urn are now 6. And out of these 6 red balls, only 4 balls are red. So we can say that probability of R2 when R1 has already occurred is 4 upon 6. Hence, by multiplying these two probabilities, that is the conditional probability of R2 slash R1, and the probability of R1, we get the intersection probability, that is probability of R1 intersection R2. Similarly, now we will apply the conditional probability one more time to calculate probability of G1 intersection R2. So to calculate probability of G1 intersection R2, what we will do? First of all, we will calculate probability of G1. That is the probability that the first ball drawn is a green ball. So again, there are 7 balls in the urn, and if we want to calculate the probability that the first ball is a green ball, so it is 2 upon 7. So probability of G1 is 2 upon 7, written just beneath equation number 4. And now we want to calculate the conditional probability that if we have drawn a green ball at the first stage, then what is the probability that the second ball is a red ball? So obviously, if there are 7 balls initially and we draw a green ball out of this urn, then now there are total 6 balls, and out of those 6 balls, 5 balls are red. So probability that the second ball will be a red ball if the first ball is green, that is probability of R2 slash G1 is 5 upon 6, because there are 5 red balls out of 6 total balls in the urn. So hence, by multiplying probability of R2 slash G1 and probability of G1, we calculated the probability of G1 intersection R2. So what is the conclusion? That we applied conditional probability twice. In the first stage, we applied conditional probability to calculate the probability of an intersection, and that was probability of R1 intersection R2. Similarly, we again applied a conditional probability, and then we calculated the probability of another intersection, that is probability of G1 intersection R2. Then we added these two intersection probabilities to get the probability of a particular event, that whenever 2 balls are drawn from this urn, the second ball is a red ball. So here what we did, we basically applied the Bayes theorem. So these are the examples that I wanted to explain you from this slide. Now coming to the exercise problem of chapter 2 that are related to conditional probability and Bayes theorem. So let me just quickly open the exercise problems. Okay, student, you can see exercise problems related to conditional probability from 2.73 to 2.77. So Which problem should I solve for you? देखिए इसमें से कौन सी आप प्रॉब्लम चाहते हैं कि मैं आपके लिए सॉल्व करूं? जी, चले मैं आपको खुद बता देता हूं, अगर आपके जहन में नहीं आ रहा तो। देखिए सबसे अच्छी यहाँ पर जो इन चारों पांचों सवालों में है, द बेस्ट exercise problem in my opinion is exercise 2.75. Why? Because it deals with numbers and students get uh, very easily the concept when it comes to be a problem related to number system. Okay, so what is the problem? Exercise 2.75, they are saying that a random sample of 200 adults are classified below by gender and their level of education attained. So obviously by gender they are divided in two categories, male and female, and by level of education they are classified in three levels, that is elementary, secondary and college level. Okay, now what is the question? They are saying that if a person is picked at random from this group, find the probability that the person is a male given that the person has a secondary education. So can anybody of you tell me that whether it is the conditional probability m slash SE that we are to calculate, or it is the conditional probability SE slash m that we are to calculate? जी, कोई आप में से बताएगा कि ये जो सवाल पहला उन्होंने पूछा है, इसमें हमसे मेल स्लैश SE की कंडीशनल प्रोबेबिलिटी पूछी गई है या हमसे SE स्लैश मेल की कंडीशनल प्रोबेबिलिटी पूछी गई है? जी, एनीबडी अवेलेबल जो इसका आंसर देना चाहे?
मेल स्लैश SE।
बिल्कुल सही, यहाँ पर इन्होंने हमसे मेल स्लैश SE की प्रोबेबिलिटी पूछी है. सो टू कैलकुलेट प्रोबेबिलिटी ऑफ मेल स्लैश secondary education, we will use the formula and we will write that probability of male slash secondary education is equals to probability of male intersection secondary education divided by probability of secondary education. So we will calculate this probability in two steps. First of all, we will calculate the probability of denominator, that is probability of secondary education. So if we are taking one person out of these 200 students, or what we can say 200 people, so what is the probability that a person chosen is having a secondary education? So obviously there are 28 plus 50 students that are having secondary education. So probability of secondary education in the denominator, we will write 78 upon 200, because in the denominator we need to write the probability of secondary education. So among these 200 people, there are 78 people that are having secondary education. So in the denominator for probability of secondary education, we will write 78 upon 200. While in the numerator, we need to calculate probability of male intersection secondary education. So can anybody of you tell me that what is the probability for male intersection secondary education? G. Perfect. So it is 28 upon 200. So for probability of male intersection secondary education, we will write 28 upon 200 in the numerator. And for secondary education, we will write 78 upon 200 in the denominator. So hence we will conclude that it is 28 upon 78. That is the answer of this question. And then obviously we will simplify 28 upon 78 and we will get 14 upon 39. So just to confirm that whether we have done this question right or wrong, just we verify this answer from the answer sheet. So I think it is here. Since it is an odd question, so I'm hopeful that there will be an answer written in the book. So Okay, so this is the answer, and obviously it is a correct answer. We calculated that probability of male slash secondary education is 14 upon 39, and the same answer is given in your book. So our answer is correct. Okay, now coming back to the exercise again. Now we will solve the second part of this problem. In the second part, they are saying find the probability that the person does not have a college degree, given that the person is a female. Again, my question is that whether it is a conditional probability question of probability of C complement slash female, or it is a question of probability of female slash C complement. सवाल ये क्या है, सी कॉम्प्लीमेंट स्लैश फीमेल है या फीमेल स्लैश सी कॉम्प्लीमेंट है ये?
C/female.
Perfect. So it is the conditional probability question that what is the probability that the person will not be having the college degree, given that it is she is a female. So basically, it is probability of C complement slash female that is required. So obviously, according to the formula, we will write probability of C complement intersection female in the numerator, and we will write probability of female in the denominator. So first of all, we will calculate probability of the denominator, that is probability of female. Why we calculate probability of the denominator first? Why? Because uh, probability of the numerator in conditional probability is always a subset of the probability of denominator. So first of all, we will calculate probability of denominator to calculate the total probability. Then we will choose one section of this total probability in the and write it in the numerator to get the conditional probability solved. Okay, so here our question is probability of C complement slash F, that is probability, and it is equals to probability of C complement intersection F divided by probability of F. So first of all, we will calculate the denominator's probability, that is probability of female. So can anybody of you tell me that what is probability of female here? G. What is probability of female?
17/39.
There are three categories of females: females with elementary education, female with secondary education, and female with college education. So probability of female means all this probability. So what is the probability of female?
So 17/112.
Probability of female is 112 upon 200. Why? Because if we are to
Hey, self
calculate,
college.
no, we are not calculating right now probability of C complement. We are calculating probability of female. So for probability of female, we will include every female. So there are 45 females in the elementary education system, 50 females having secondary education, 17 females having college education. So in total, females are 112. And since we have taken only one person out of the 200 sample, so we will write that probability of female is 112 divided by 200. So in the denominator, we will write probability of female, and it is 112 divided by 200. Now in the numerator, we need to calculate probability of C complement intersection F. That is probability that the person chosen is female, but she is not having the college education. This is probability of C complement intersection female. So now what we will write in the numerator? G. What we should write in the numerator?
So 95/112.
Perfect. So we will write 95 divided by 200 in the numerator. In the denominator, we wrote 112 upon 200. So obviously, the 200 of numerator will be simplified with the 200 of denominator, and we will get the answer 95 over 112. So we can easily verify that this answer is also correct. So since it is only a 1 hour lecture, so let us go to the next exercise and just do one or two questions from there to basically understand the Bayes theorem. Okay, so this is the exercise related to Bayes theorem, and to cut it short, we can do a very good question here. That is question number 2.101. Why I recommend this question to you? Because it is uh, a question that is using both the Bayes theorem and the conditional probability at the same time. So let us start this question. In exercise 2.101, they are saying that a paint store chain produces and sells latex and semi-gloss paint. In short, there are two different types of paints that are basically sold in this store. One is the latex type of the paint and other is the semi-gloss paint. So there are two paints available. The probability that a customer will choose the latex paint is 75%, that is 0.75. And if he or she is choosing the latex paint, the probability that he or she will take a roller is 60%. Okay, so choosing the latex paint has a probability of 75%, and after choosing the latex paint, the probability that he or she will choose the roller is 60%. Similarly, obviously, if the probability for latex paint is 75%, then what would be the probability for semi-gloss paint? There are only two paints now. So if the probability of latex paint is 75%, then the probability of semi-gloss paint is obviously 1 minus 75%, that is 25%. So he or she will choose the semi-gloss paint. It has a probability of 25%. Now, after choosing the semi-gloss paint, the probability that the customer will choose the roller is 30%. So this is the situation that a customer can buy two different types of paints. The probability that he will buy the latex paint is 75%. The probability that he or she will buy the semi-gloss paint is 25%. And after buying the latex paint, the probability that the customer will buy the roller as well is 60%. Similarly, after buying the semi-gloss paint, the probability that the customer will buy the rollers is 30%. Okay. Now, what is the question? They are saying that a randomly selected buyer purchases a roller and a can of paint. That is, a customer buys both the roller and a paint can. What is the probability that the paint is latex? So it is a very simple question if you know how to deal with the Bayes theorem and the conditional probability. In the first statement, they are saying that a randomly selected buyer purchases a roller and a can of paint. That is, in the first statement, they are making sure that the customer is doing intersection of paint and roller. So there are two possible intersections: probability of latex intersection roller and probability of paint semi-gloss intersection roller. So if you recall, in the start of this lecture, I told you what is Bayes theorem. to calculate the probabilities of different intersections by applying the conditional probability again and again. So this is the case here. First of all, we will calculate two intersections. And for these two intersections, we will calculate uh, we will apply conditional probability twice. For example, for probability of latex intersection roller, we will write probability of latex, that is 0.75, multiply by probability of roller slash latex, that is 60%. So we will write 0.75 multiplied by zero point 0.6. This is our first intersection, probability of latex intersection roller. 0.75 multiplied by 0.60. So what is the answer? We can write 0.75 multiplied by 0.6 and the answer is 0.45. So this is the first intersection probability, that is probability of latex intersection roller. Now we will calculate the second intersection probability using the conditional probability. That is probability of semi-glass intersection roller. So probability of semi-glass is 0.25 and probability of roller slash semi-glass is 30%. So we will write probability of semi-glass intersection roller equals to 0.25 multiplied by zero point 0.3, that is 0.075. So the first intersection was having a probability of 0.45. The second intersection was having a probability 0.075. So the total probability by adding these two probabilities according to Bayes' theorem is basically 0.525. So what we did, we calculated two probabilities of two intersections, probability of latex intersection roller and probability of semi-gloss intersection roller. Then we added these two probabilities and we got the total probability as 0.525. Now this is probability of roller. To get a roller, obviously we will do this thing. Okay, now the second part of this question is saying that what is the probability if the first part was saying that the customer was having both roller and cane, and now they are saying that what is the probability that the paint is latex. So this is a conditional probability question, that if it is given that the customer is buying roller, then what is the probability that he or she will buy the latex paint. So in the denominator, we require the total probability of roller, and in the numerator, we require only that subset of the roller probability that is using uh, the semi-glass. Sorry, that is using the latex version. So in the denominator, we will write probability of roller, that is being displayed on the calculator screen, that is 0.525. And in the numerator, we will write probability of semi-glass intersection roller. So probability of latex intersection roller. So probability of latex intersection roller was 0.45. So our answer would be 0.45 divided by 0.525, that is 0.857. So you saw that what we did in this question, first of all, we calculated two probabilities related to intersection. Probability of latex intersection roller, then probability of semi-gloss intersection roller. Then we added these two intersection probabilities to get the total probability of intersection. And then what happened that when we added these two probabilities, we got the probability that the customer is using roller. The customer can use roller in two ways: by buying the latex paint and then buying the roller, or by buying the semi-gloss paint and then buying the roller. So hence by adding these two intersection probabilities, we calculated the probability of roller. Now the question was that if it is given to you that the customer is using the roller, what is the probability that he or she will use the latex paint? So therefore, we know that we are to calculate probability of latex paint slash roller. And for probability of latex paint slash roller, we can write probability of latex intersection roller in the numerator and probability of roller in the denominator. So probability of latex intersection roller was 0.45 and probability of roller, that is in the denominator, was 0.525. We divided 0.45 with 0.525 to get the answer of this probability, and it is 0.857. So let us confirm it from the answer sheet that whether it is a correct answer. So the question is 2.101. Again, we go to the answer sheet. And you can clearly see that the answer of question 2.101 is the same as we calculated. It is 0.857. So hence the conclusion is that how we apply Bayes theorem. First of all, we apply conditional probability again and again to calculate some intersections probabilities. Then we add those intersection probabilities to get the probability of a particular event. Like in this last question, we calculated two intersections, probability of latex intersection roller and probability of uh, semi-glass intersection roller. Then we added these two intersection probabilities to get the total probability of roller. That was 0.525. So this was the completion of Bayes theorem. We applied conditional probability twice. We calculated two intersection probabilities. We added the two intersection probabilities to get a probability of a particular event. So here we basically completed the Bayes theorem portion of the question. After completing the Bayes theorem portion, we applied the conditional probability again because it was a bit complex question that what
Sir,
they did.
can you please solve it on the paper?
Yes, we can
Because
solve it on the paper, but due to shortage of time, basically, I
sir,
told you
because two,
everything like this. But what we can say, we can easily write it in 3 lines, na? Uh, because it is a PDF, so I can't write it here. But I tell you, you can write it on your copy. First of all, write probability of L intersection R. Okay. First of all, write probability of L intersection R. It is equals to 0.75 multiplied by zero point 0.6, that is equals to 0.45. Okay. So the first line is probability of L intersection R, which is equals to 0.75 multiplied by zero point 0.6, which is equals to 0.45. Then in the second line, we will write probability of S intersection R. So probability of S intersection R will be equals to 0.25 multiplied by zero point 0.3, that is 0. I think 0.075. Okay. Then in the third line, we will write probability of R equals to probability of L intersection R plus probability of S intersection R. So probability of R equals to 0.45 plus 0.075, which is equals to 0.525. In the fourth and the last line, we will write probability of uh, L intersection, sorry, probability of L slash R equals to probability of L intersection R divided by probability of R. So for probability of L intersection R, we will write 0.45, and for probability of R we will write 0.525, and hence we will get the answer 0.857. Hope you will follow these intersection, and you can easily write this answer in your copy for the sake of obviously your memory. So inshallah, we will cover. This is basically the end of the midterm syllabus. Here we basically completed the midterm syllabus. I assigned you some assignments, and the deadline is, I think, this Sunday. So make sure that you submit your assignments as per the deadline. And inshallah, from the next week onwards, we will cover the course that is basically included in after the midterm or in the final term exams. Okay. So if you want to ask any question, you can ask it right now.
Can you please solve another question for base theorem because it's too confusing?
Okay, we can solve it in the next class because I think we are having only 1 minute left. So base theorem is not so easy that we can solve a question in less than 1 minute time. So inshallah, we can you what you can do, you can solve some questions at your own, and if you find some difficulty, you can come up with those questions in the next class, and inshallah we will solve those questions for you in the next class. Okay, never
Sure, sure.
mind, we are available here for solving any question you need to solve. Okay, so don't you worry. But obviously in an hour class, in 1 hour class, it is very difficult to solve so much questions, na? So what we do, we give you an idea that how to solve questions related to this particular topic, and if you will follow my instructions, inshallah you will always get to a correct answer. Okay, so what is the conclusion of Bayes theorem? We will apply conditional probability again and again to calculate some probabilities of intersections. Then we will add up, or we will sum those intersection probabilities to get the total probability of a particular event. And this is all about Bayes theorem. Okay. So inshallah, we'll see you in the next class. Till then, take care and Allah Hafiz.
Allah Hafiz.